In this video, we're going to look at how to solve an equation using its graph. So here we have the graph of y equals negative 1/5 x plus 7, and we want to solve these equations over here. Now certainly you could solve all of these algebraically by subtracting 7 from both sides and then dividing by negative 1.5. And you should definitely know how to do that. But the purpose of this video is to help you relate the graph with the equation and the idea of inputs and outputs. So every point on this graph over here represents an x and y value that makes this equation true. All right, so for example, we have this point here, which is on the graph. When x is 4, y is 1. So that means if I put 4 in here for x, multiply it by negative 1.5 and add 7, the result will be 1. So notice that these values here are in the spot in the equation where the y value is. And so what we're trying to do is to find the value of x that will give us a y value that's shown in yellow. So in other words, that will be the second coordinate of any point that's on the line. All right, so in the first case, we're looking at a y value of 4. All right, this is telling you that y is equal to 4 on our line over here. So we're going to go over here and we're going to look at when y equals 4. These are all the points when y equals 4. And we can see that this point right here on our line has a y coordinate of 4. All right, it has an x coordinate of 2 and a y coordinate of 4. So the value x equals 2 will make this equation true. When x equals 2, y will equal 4. And you can verify that by plugging 2 into the equation, and it's always good to verify stuff if you can, and see that it actually does come out to 4. All right, negative 3 plus 7 is 4. All right, let's try the next one. So negative 2, y equals negative 2. Take a look at the graph. Where on the graph can you find a point where the y coordinate is negative 2? All right, so you should be looking right here. That's where y is negative 2. So we want to see where does that intersect our line. And it looks like we have an x value of 6. All right, so the x value that solves this equation is 6. Why don't you try the next two? Maybe pause the video, try the next two, and unpause it when you're done. Well, this next example is kind of a special case. It's when y is equal to 0. So when y is equal to 0, we are getting a special point on our graph, which is the-intercept. Y equals 0 is on the x-axis. So the point where the line has a y value of 0 is where the line crosses the x-axis. Now, this one's not as easy to tell, is it? It's kind of estimating. It looks like it's a little bit past 4.5. So maybe I guess 4.6. So I'm actually going to come over here and I'm going to say x is approximately 4.6 because I'm not exactly sure. Now, if I wanted to be exactly sure, then what I would do is I would solve this algebraically. All right, minus 7 and divide by negative 1.5. All right, how about the next one? 5.5. Let's see, x is 5.5. So right about here, or sorry, y is 5.5. Y is 5.5, and we want to find the x value that will give us that. Looks like right here we have a point on the line that is up 5.5 units when x is 1. And I'm pretty confident that's exact. I'm going to go ahead and check that and make sure. Negative 1.5 times 1 is negative 1.5 plus 7 will give me a positive 5.5. So that is exact. All right, so I hope this video helped you see the relationship between a linear equation and the graph of a line.